One other question we can go over is A. So we still have our same pumping lemma requirements for context-free language. For the string omega greater in length than the pumping length, omega is composed of the substring u, v, x, y, z. The length of vxy is less than or equal to the pumping length p, and the length of vy is greater than or equal to 1. And for all I greater than or equal to 0, u, vi, x, y, I, z has to be an element of L. So here we go. Here's A. The language is 0n, 1n, 2n, where n is greater than or equal to 0. So we're going to create our string omega, 0p, 1p, 2p. So that means p0s, p1s, then p2s, which is going to be equal to u, v, x, y, z. This follows the rules of the language, so this is an element of the language. We can look at the two cases we're going to have. So our string is going to be some number of zeros, followed by some number of ones, followed by some number of twos. And what's important here is that we know that vxy has to be less than or equal to the pumping length. It's one of the rules. That means that vxy, this center of the string, can only sit in one of 5 positions. It can sit right here, where vxy has to be less than p, so it can be all zeros, it could be all ones, and it could be all twos. It's important. This is what limits the number of cases. It's because we set our string to be p zeros. It could be any length n, but we set it to be the pumping length, and this vxy has to be less than the pumping length. So it couldn't be 0 through 1. That would be too long. However, there's 2 other places that vxy can sit. It can sit and straddle 0, 1, or it can sit and straddle 1, 2. You could write all these out, but they're 2 fundamental cases, so that's why I wrote them, case 1 and case 2. You could write them all on your homework, on your test, but if you get at the core of what are the fundamental different cases, you're fine. Case 1, vxy contains only zeros. This would be true if it contained only ones or it contained only twos. If you apply rule 5, where for any I this has to be an element of the language, you would get u, v2, x, y2, z. This would not be an element of L, because your 2 for the y's would only be zeros. So you would end up adding more zeros to your string, but no more ones or twos, which would result in a string that didn't have an even number of zeros, ones, and twos. You'd have more zeros than you'd had 1 and 2s. So therefore, it would not be part of the language. Case 2 would also fail by this same logic, but case 2 would also have to deal with the fact that vxy, which sits on the border, for one example, contains zeros and ones, because it sits on the border. So if you applied the final rule and made I equal to 2, you would have u, v2, x, y2, z. This would not be an element of L because it would create a reversal of zeros and ones, because you would have in the v or in the y, you would potentially have x, you would have zeros, and then in the y you would also have potentially ones. And even if the x value sat exactly on the middle point of 0, and if x sat on the last 0 and y sat on the first 1, you would still get an additional zeros created and additional ones created, which would result in having more zeros and ones than you had twos. So it would be covered under the first case. And you would also have the issue of if v or y crossed over between 0 and 1, you would get a string that was out of order, where 0 and 1 would repeat. So you would have a string 0, 0, 0, 1, 0, 1, 0, 0, sorry, 0, 0, 0, 1, 0, 1, 1, 1, 1, 2, so on and so forth. And that wouldn't be in the correct order, which would also mean it wasn't an L. So that's the proof for A. There's a lot more you can write out, but this is the very bare bones.